Okay, so today's lesson is lesson 8 and it's on complex numbers, which is section 4.8 in your book. Our content objective is to identify and perform operations with complex numbers and find complex solutions. And our language objective is to use the correct terminology to describe complex numbers. So we're going to jump in by talking about a sort of precursor or building block to complex numbers, the imaginary unit. So the imaginary unit is the square root of -1. So many of you might think, well, you can't take the square root of a negative, which is true, which is why we end up with the imaginary unit. So the square root of -1 is the imaginary unit, or I, because we can't really take the square root of a negative, so we sort of work around it by using this imaginary unit to manipulate equations in ways that we'll practice later on in these notes. So we know this, if the square root of -1 is I, then I squared would similarly be -1. So since the square root of this is I, that squared would have to give us -1. And the reason we're talking about this is because for any positive number A, the square root of -A is equal to the square root of -1 times A, which would be equal to the square root of -1 times the square root of A, which would give us, since we know the square root of -1 is I, it gives us I times the square root of A. So we can rewrite a lot of our, we can rewrite a lot of radicals by using our imaginary unit. So for example, if we had the square root of -5, we could rewrite this as I root 5. So we can take out the negative or take the square root of that negative sign and put an imaginary unit in front. So this would be a complex number because it's using the imaginary unit. So any number, or a complex number, is a number that uses the imaginary unit, and we'll talk about that in more detail. Before we go to that, I really quickly want to make sure you guys can simplify using the imaginary unit. So I want you to try to simplify these two radicals really quick. We have the square root of -18 and the square root of -12. So using this information and your knowledge of simplifying radicals, try those out on your own. I'm going to go over them now. So I can rewrite -18 as -1 times 9 times 2. So I broke that into a lot of different pieces. The square root of -1 I know is I. The square root of 9 I know is 3. So I have 3I that I've now taken out of the square root, but I'm left with root 2 there. So my simplified form is 3I root 2. I'm going to do a similar thing here with -12. I have -1 times 4 times 3. I know if I take the square root of -1, I get I. The square root of 4 is 2. The square root of 3 I cannot do without getting an irrational number. So my answer is 2I root 3. Jot down any questions you have on those, but I'm going to jump into now our complex numbers, or the definition of complex numbers, which is the focus of today's notes. So complex numbers are written in the form A plus BI, where A and B are real numbers. So to sort of give you a visual breakdown of where these complex numbers fall in our category, or actually before I do that, so our complex numbers are written like this. The first term, A, is a real number, or the real part, whereas the part with the I, or the imaginary unit, is the imaginary part of our complex number. So our complex numbers have both real parts and imaginary parts. That's why they're complex. They're there's multiple parts, multifaceted. So when we're talking about them, they kind of fall into these categories. If we have this box, we have our real numbers over here. And these would be numbers that can be written, or would be written, as A plus 0I. So they don't have any imaginary unit, because 0 times I would just be 0. So basically real numbers are numbers with no imaginary part to them. So our real numbers that we've worked with until this point are numbers with no I or no imaginary component. Then we have imaginary numbers over here. And these are in the form, like we just talked about, a plus bi, only b does not equal 0. So these are the complex numbers with multiple parts, but you can also have pure imaginary numbers like we practiced or what we were working with up here in our last examples. So pure imaginary numbers are numbers in that form, but a is going to be 0, so it'd be 0 plus bi. So it's numbers with no real component. So we can either have real component, no imaginary, which gives us real numbers that we're used to working with, imaginary numbers with both real and complex or real and imaginary components, and then pure imaginary numbers that have no real component and only imaginary components. So that's kind of the gist. That's the big conceptual component of this, but the next thing I want to go to is how we're actually going to manipulate and use these complex numbers. I'm going to flip the page for this. So for this, we're going to start with adding and subtracting our complex numbers. And this is not too terrible. It's really just like adding and subtracting numbers with variables. So we treat our I kind of functions like a variable, so you can only combine it with like terms. So I'm going to put a little star here. So you're going to add or subtract like parts. And our example, I'm not going to go through all the steps because I think you guys will be able to follow along, but I want us to add 5 minus 3i minus negative 2 plus 4i. So I'm adding or subtracting, these two complex numbers. So first thing I need to do is distribute the negative so I can get rid of those parentheses. So I have 5 minus 3i, negative times negative 2, or negative 1 times negative 2 is plus 2. And then negative 1 times negative 4i is negative 4i. Now I'm just going to combine like parts. So I'm going to combine my 5 and my 2 and my negative 3i and negative 4i. So when I do that, I end up with 7 minus 7i, and that is my solution. So the key thing here is you're only combining like parts. Imaginary can only combine with imaginary. Real can only combine with real. So we're going to do a quick check with that. I want you to add 7 minus 2i plus negative 3 plus I. Go ahead, try that on your own. I'm going to go over it now. So I'm going to do 7, that's just plus, so minus 3, and then negative 2i plus I. When I combine these like parts, I get 4 minus I, and that is my solution. So that's adding and subtracting. Multiplying is going to be similar. So just like foiling with a variable or multiplying, distributing in a variable, we're going to multiply things in that exact same fashion. So our example, I want us to multiply 4 plus 3i times negative 1 minus 2i. And first step, we're going to FOIL or distribute it out. So when I do this, I do 4 times negative 1 and I get negative 4. So I do my first terms, I do my outer terms. So 4 times negative 2i is negative 8i. I do my inner terms, 3 times negative 1 is negative 3i. And I do my last term, so 3 times negative 2 is negative 6i squared. So then the next thing I'm going to do, as you might remember from our earlier notes, I squared is equal to negative 1. So I'm going to substitute negative 1 for I squared. So I'm now going to have negative 4 minus 8i minus 3i, which we'll combine those. If you combine those in the last step, that's fine. Minus 6 times negative 1. Now I'm going to, last step, simplify. So I end up with negative 4, negative 6 times negative 1 is plus 6. Negative 8 minus 3 is negative 11i. So then negative 4 plus 6 is 2 minus 11i, and that is my final solution for that problem. We're going to do a quick check with that to make sure we're all on the same page. I want us to do, I'll do 2 if we can fit them here. I want us to do -6 plus I times -6 minus I. And the other one I want you to try is 2 minus 3I and 4 plus 5I. So try those both on your own. I'm going to go over them now. So I FOIL it out and I get 36 plus 6I minus 6I minus I squared. My 6I and 6I cancel out and I'm left with 36 minus, and I'm going to substitute -1 for I squared, -1, which becomes 36 plus 1, which is 37. So my final solution for that expression would be 37. I'm going to do the same process here. So 2 times 4 is 8. 2 times 5I is 10I. -3I and 4 is -12I. And then minus 15I squared. I combine my like terms and I get 8 minus 2I. -15, I'm now going to do times -1, which becomes plus 15. So I have 8 plus 15 minus 2I, which is 23 minus 2I, which is my final answer. All right, that's all for today. Make sure you write down any questions, comments, concerns you have so we can go over them together in class.